We're not done for today. We're done for this.
It's going.
Are we back on?
Teachers and parents.
All right.
Like,
Welcome to part 2.
Yeah.
All right.
God, that's so much.
There are 2 kinds of waves that we need to discuss, and I let wave out, so I didn't know if you knew what we were studying, but once I gave you the handout, you knew, so that was dumb. So I'll just go ahead and put in the word wave. Would you write down the definition as it is, and then we'll decide what it means. There are 2 kinds of waves. One is, so there's 2 kinds of waves. They are transverse. That's the first one. So get that one down. Transverse wave is a wave whose propagation is perpendicular to its oscillation, which doesn't make a lot of sense until I show you or explain what those words mean. And then, besides transverse, there's longitudinal.
Oh, I remember that. Heard that word before.
That's a wave whose propagation is parallel to its oscillation. All right, get that down before I have to erase it, because I'm running out of board space. Brian, you feel all right? I can erase what's above while you're writing down those last 2. Alright, let's talk about a transverse wave, first of all. And this is saying it's a wave whose propagation, remember that just means it's going, it's moving. We talked about that already. A wave whose going is perpendicular to its oscillation. And another word for oscillation is, say, vibration. Maybe that makes a little more sense now. Transverse wave is a wave whose going is perpendicular to its vibration. All right, maybe not. Let me show you. So this wave, like this, the one that you're used to seeing most likely, is going this way, so it's moving in that direction. I brought a slinky to demonstrate. Did you bring yours?
I couldn't find it.
Oh, thanks for looking. So, can you envision once a wave is starting that the crests are moving along, either this way or that way? So I picked this way. So it's going this way, but its oscillation, its up and down portion, its repeating portion is this way. And those are perpendicular to one another. So it's going this way, but it's vibrating this way. So that's called transverse. Right here, that's a transverse wave. So let me demonstrate. 1. We're going to have a space. Probably the biggest space is right here.
Can we try and make it go down the stairs?
Now let's do the slinky
No,
from
we don't
Toy
need to
Story.
go anywhere. Alright, just hold the edge of this.
Toy Story's
Alright, so here comes a transverse wave. It'll start at my hand and it'll go over to her. It'll probably come back and forth. You've seen this before, right?
Whoa. Whoa.
I have to look quick. It moves pretty fast. Like if I had a longer, fatter slinky, you could see it move slower like that. Alright, we're going to need that again in a second. Here, Alex, let's see if I can get one going. I think these are the dollar store versions. So Alright, can you see it? It moves pretty fast. Go ahead, you can make one, Alex. Alright, let me try. Keep it down. I think that was pretty good. Yeah, I can see that one moving along.
Gnarly.
Alright, gnarly.
Gnarly, man.
Alright. So, you can see that it's oscillating, it's vibrating up and down, yet it's moving perpendicularly to that. Alright, so then what would longitudinal look like? Here it is, did you have time to get both? Alright, a longitudinal wave is propagating parallel to its oscillation. So this was transverse. Let's look at a longitudinal sketch. And I'll show you with the slinky. Longitudinal. So here we have a clumping. Then we have a spreading. And we have a clumping again. Spreading, clumping. Spreading, clumping, spreading. That is a longitudinal wave. And the substance, whenever we have a medium for all our waves, is clumping together and then spreading out, clumping and spreading out, clumping and spreading out. This is moving. These clumps are moving in this direction. And the oscillation is also, the vibration is also in that direction. So it's very hard to visualize on the board that that is happening. So Mr. Slinky has to help us. When I was growing up, these things were new on the market. Laugh, laugh. And there was a jingle that went around with it. I'll have to play it for you. All right. I'll come over there as well. So I'm going to cause, let's go not quite so tight. All right. So I'm going to cause a clumping. And that clumping should move back and
Whoa, I see it
forth.
moving.
Alright, that's longitudinal. Alright, are you
Get
getting
that
that?
close,
Did you get that on the other one too? Did you?
No, I missed that one.
Alright, why don't we show them then? Alright, this is going to be the clumping one. Because we didn't get the other one on video, we'll show you a transverse. Alright, here's longitudinal, clumping. It's easier almost to see the
flash.
The clumps move down, that's called longitudinal. Alright, here comes a transverse. Alright, very good. Thank you.
Alex tries into it.
Yeah.
Alright, let me show you the jingle. See if I- Yeah, it took me like 20 pulls of this morning to get it to stay. That's one reason I come in early, to get the screen. Oh! Wow! The magic touch. Alright, I'll show you the commercial I grew up with. It's like still in my head some days, it's that bad.
Oh no, it's gonna be stuck in our head.
Yeah, that's gonna be stuck now. I had to see it a billion times before it stuck.
Alright.
Yeah, that's good.
Should I record this?
Yes, you should definitely record this. Absolutely.
I figured out how to do it. I just couldn't do it.
Alright,
I couldn't do any of it. You have to plug it back into the
because we don't have sound, I put the sound on my phone, so it's not gonna be real loud. MD, could you fix the lights?
What eggs?
A little bit of the outcry door.
Alright, so it's probably not gonna be in sync, but you get the idea. Ready?
Oh, you can't smash it. It's like I don't want to.
You have to be quiet because my phone's not that loud.
There we go.
I want to go, but it takes like $80.
It's very important.
Yeah, last night, so.
Oh, we don't have it on? I guess I bet.
It just says video mute, press
Alright.
blank screen again to display video.
Yeah, I need to turn
Oh, do
the
you?
video. I had not muted it. That's where I did.
Yeah, so it's like an annual thing.
Let's get all systems go here.
So yeah, they're like,
How's your
so
eyes?
great. They only do like 5 songs now, right? They were like the last accident.
Has to wake up now. Alright, I can enlarge it. Let's see what it sounds like.
No, you actually got the it's magic stones for dragon tails.
I saw this commercial probably 500 times.
Well, you saw this commercial back in your day?
I sure did.
So this is like the new thing, and we're so hyped over it. Slinky. Oh. How do you do that?
What is it?
There they are. And we can still buy them today.
What? I want to train.
Now let's see what there are. There's a hippo,
Oh my
gosh.
green, and there's one other, I forget.
Well, there's
Dog.
Slinky Dog
There's a
because
dog.
Toy Story.
I'm so weird. I want to train.
Oops.
Just hit cancel.
I just haven't done it
You
yet.
never know
But we
what'll
can just
pop
watch
up
the
next on these things.
Classic commercial.
She's actually.
Oh.
The video camera still on?
Yeah,
Okay.
I got all this.
So you got her
It's like the most
fuzzies
important
on.
date, like,
Yep.
every
I
Christmas
don't know
has
if
to be
they
here.
can hear
If you're
very
not,
well.
That's true.
it's the biggest date.
You have to watch by yourself.
of our
I
entire
just close my eyes.
Go watch the Slinky jingle.
Did you just see if they were
Yeah. Without fail.
The
Without fail.
commercial must have
Something I
worked
noticed
because we're
it,
still
but
buying
I
them
was
today.
She just did.
They tried it
For about 2 minutes.
No good.
Yeah, that's how
Then they get
Magic
tangled.
touch.
It's funny him to try to go downstairs.
One of these sound waves, one of these represents sound waves and one of them represents light waves. So it's interesting how different light and sound are, yet they're both waves. So, which one, do you think it's transverse or longitudinal, is a model of sound waves? What would you think? All right, I am positive, I am very positive that when I was in 4th grade or somewhere along the line, we were given a line like this, and we're given amplitude and lambda or lambda and all the wavelengths and the trough and the crest, and we're told it was sound waves. That's not it. Here is what sound